Hello students, today we will discuss about bounded and unbounded sets. See, lower bound and bounded below. Take any real number, suppose m belongs to real number, then m is less than or equals to x for all x belongs to s. When you are taking any set, then this m is less than or equal to every element in the given set, then we can say it is a lower bound and this set is said to be bounded below set. Similarly, upper bound means any real number, you take any real number, then that real number should be greater than or equals to every element in the given set, then that element is said to be, that number is said to be upper bound and the given set is said to be bounded above. See one example. See here, I am taking one set and take any real number. That must be less than or equals to every element in the given set. So, obviously we are taking the smallest number in the given set, suppose 1, then which is a real number. Then this 1 is equal to 1 and 1 is less than 2, 1 is less than 3. That means 1 is less than or equals to every element in the given set. So, what we can say? 1 is the lower bound. So, take any real number. That real number need not be belongs to the given set. Suppose I am taking any another real number, 0, which is also what? Less than or equals to every number in the given set, isn't it? 0 less than 1, 0 less than 2, 0 less than 3, like this. So, 0 is also an lower bound. Similarly, any number which is less than 1, that is 0, minus 1, minus 2, minus 3, whatever you are taking, that numbers are all less than given set. That's why these are all what? Lower bounds. So, what are the lower bounds for this given set? 1, 0, minus 1, minus 2 up to endless. So, how many lower bounds for any set? We may have infinite number of lower bounds. Similarly, out of this all lower bounds, which one is the greatest one, which is called greatest lower bound, which is also called infimum. So, what is the infimum for this? 1. So, this 1 is least number in the given set, but which is the greatest of all lower bounds. So, simply what we can say, infimum is 1. Similarly, supremum means when you are taking upper bounds. See one example. See one example, 0, minus 1, minus 2. This is in decreasing order, right? So, which one is the greatest one? 0 is the greatest one. So, can I take 0 here? Yes. So, 0, suppose we are taking from real numbers, then 0 is greater than or equals to all numbers in the given set, isn't it? 0 is greater than 0, equal to 0, 0 is greater than minus 1, 0 is greater than minus 2, like this. So, 0 is greater than or equals to every element in the given set, that's why 0 is an upper bound. Similarly, any number which is greater than 0, that is suppose I am taking 1, which is also a real number, which is greater than all the elements. 2, which is also greater than all the elements. 3, that means 0 is an upper bound, then any number which is greater than 0, which is also an upper bound. That's why 0, 1, 2, 3, 4, which are all upper bounds. See here, when you are taking in descending order, if you are confusing, simply we can do one thing. We can make it into ascending order like this and so on up to minus 2, minus 1, 0. Now it will be very clear to find the upper bound, because when you are saying in the ascending order, 0 is the greatest one. This is greater than or equals to every number in the given set. That's why 0 is an upper bound. And any number which is greater than 0 like 1, 2, 3, 4 all are upper bounds. So, similarly, how many upper bounds for any set? Infinite number of upper bounds will be there. And out of this all upper bounds, which one is the least one? Yes, 0, 1, 2, 3, 4 and so on. Out of these all upper bounds, which one is the least one? 0 is the least one, which is called least upper bound, which is also called supremum. So, what we observe here, you take any set, make it into ascending order. Suppose it is in ascending order, no need to convert. Suppose it is in descending order, converting into ascending order. Which one is the greatest, greatest number, that means right end will be there, then this will be the supremum, because this is an upper bound. Any number greater than 1 is also an upper bound. So, out of this all, least upper bound is nothing but 0. That's why which is supremum. In the same way, when you are taking any increasing order number, see here, then it is having left end. Left end means it is the least one, right? Which is less than or equals to every number in the given set. That's why it is called what? Lower bound. And any number which is also less than 0 is also a lower bound. Out of these all lower bounds, which one is the greatest one? 0 is the greatest one. That's why it is greatest lower bound, which is also infimum. So, by seeing the question, what we have to take is, suppose it is in descending order, then make it into ascending order. Yes, right end is there. So what we can say, this is the supremum, right? And here in the left side there is no end, so it has no infimum. See this example. It is in ascending order. It is having left end. So infimum is 0. It has no right end. That's why there is no supremum. Like that, easily we can guess. See this example. It is in ascending order. Yes, it has right end. So obviously it is an upper bound. And what are the remaining upper bounds? 2, 3, 4, 5, all are upper bounds. Out of this, least upper bound is 2. That's why supremum is 2. See this example. 0 plus or minus 1 plus or minus 2. We are writing in a proper way. What will happen? There is no right end. There is no left end. That's why what we can say? We can't guess lower bound. We can't find upper bound. That's why it has no supremum, no infimum. So take this example. See a finite set, it is having left hand, at the same time it has also having right hand. So what we can say, easily we can say, what are the lower bounds here? 1, 0, minus 1 and so on are lower bounds. Which is the greatest lower bound? 1. So which is called infimum. And what are the upper bounds here? 5, 6, 7, 8 and so on. Out of that, what is the least upper bound? 5, which is called supremum. So by seeing the question, easily we can find infimum and supremum. In the set, what is the right hand value, which is called supremum? Left hand value is nothing but the infimum. But here is one different problem. See here. Suppose 1 by n. 1 by n is a sequence. So what are the terms for 1 by n? When you are taking n equal to 1, 2, 3, 4, then 1, 1 by 2, 1 by 3 will come. So it is obviously in descending order. So make it into ascending order. Then right hand will be there. So obviously what we can say, it is a supremum. So supremum is 1. So is there any right left hand or not? Let us check. How to check means, like this problems, one sequence is given. When you are taking an ascending order, which side is the end? Suppose right side is the end, supremum we are finding. To find the left side value, left hand value, is there a number or not? To check that one, first find out the limit value, limit of 1 by n. As n tends to infinity, what will come? 1 by infinity is 0. So left hander, it is near to which value? Exactly 0, because when you are substituting any natural number, what will come? Any some small quantity, 0 point something will come. 1 by 100, 1 by 1000, 1 by 1 crore. What will happen? Any positive value which is greater than 0 will come, but it can't be a negative value, isn't it? So it is near to what? This limit is near to up to 0 only. So can I guess the left side end is 0? Yes, that's why what we can say, infimum is 0 here. So any set which is also having infimum and supremum, or which is also bounded below and above, then we can say this set is said to be bounded. So which is having lower bound, that's why it is bounded below. Which is also having upper bound, that's why it is bounded above. So it is both bounded and below and above, then we can say this is bounded. See another example. Closed interval AB. Closed interval AB means any real number which is lies in between A and B and also equal to A, equal to B. Suppose I am taking here 1 to 5. What will take 1 to 5 closed interval? So this includes 1, this includes 5, and also in between 1 and 5, 1.1, 1.2 up to 4.99999. This is also what? It is belongs to the given set. Suppose I am taking 5.0001, then it does not belongs to this one. Up to 5. 5 is the right hand, 1 is the left hand. That's why what we can say, infimum is 1, supremum is 5. In general, infimum is A, supremum is B. So it is also having both. That's why it is a bounded set. See one open interval. Open interval means it excludes A and B, of course, but any number which is lies in between 1 and 5, suppose I am taking 1.1. Yes, 1 is less than all the elements of this interval, isn't it? 1.1, 1.2 and so on up to 4.99 and so on, right? So 1 is the lower bound, and 0, minus 1 and also all are lower bounds, and out of this greatest lower bound is 1. So even though it is given for the open interval, simply we can say infimum is 1. At the same time, what is upper bound here? 4.99 is, what is that? 5 is greater than all the interval elements. So 5 is an upper bound, and we have more upper bound, 6, 7 like that, and out of this least upper bound is 5. So whatever it is given, either closed bracket or open or semi-closed, semi-open, whatever you are taking, infimum is A and supremum is B. That's why they are all bounded sets. Now, see this singleton set. Singleton set means obviously A is infimum, A is also supremum, which is a bounded set. Also, we have some formulae. Infimum of A plus B, we can split it infimum of A plus infimum of B. Similarly, for supremum and infimum of K into A, we can take K outside. If K is a positive number, then K into infimum of A. If K is negative, then infimum of minus A is nothing but supremum of A. That's why K into supremum of A if K is less than 0. Similarly for supremum. So, infimum of minus A is nothing but supremum of A, because when you are taking 1, 2, 3 and so on. So, here 1 is the infimum. Obviously, we know that 1 is the infimum. When you are taking minus 1, minus of this one, what will come? What will come here? This is the least value out of this all, whereas this is the greatest value out of this all. So, infimum will become supremum when you are taking minus of the values. That's why infimum of minus A is equal to supremum of A, and supremum of minus A equal to infimum of A. Similarly, infimum of A minus B is nothing but infimum of A minus infimum of B is nothing but supremum of B. Similarly for this one. Similarly, constant sequence means it is defined by C. That means when you are taking any number like 1, 2, 3, 4, 1, then the range value is C. 2, C. 3, C. For any value, the range is only a constant, then we can say it is a constant sequence. Now, bounded and unbounded. Already we discussed bounded above. Suppose Sn is bounded above, what we can say? That number is greater than or equals to all sequence. Whereas previously we are discussing for functions, here instead of function we are taking a sequence. This definition is same of course, and suppose you take any number which is greater than or equals to all the sequence elements, then we can say it is an upper bound, and we have infinite number of upper bounds, and least upper bound is said to be supremum, right? So see this example sequence. Then when you are finding the sequence elements n equal to 1, n equal to 2, then you are getting sequence elements. See here, then it is in decreasing order or increasing order? Yes, it is in decreasing order. So make it into increasing order, then this will be the greatest one, so which is called the supremum value. So what we can say, if it is having supremum in the sense it is upper bound, having upper bound, that's why it is a bounded above sequence. Similarly, bounded below sequence means you take any number, that number is less than or equals to all sequence numbers. See this example. Suppose when you are taking the sequence elements as 2, 16, 54, out of this all, this is the less than value. That's why this is the lower bound. Any number which is having lower bound means it is bounded below sequence. Like this we can consider. See, bounded sequence means a sequence which is both bounded above and below, which is called the bounded sequence. So, Sn is a sequence, it is bounded by lower bound and upper bound, then we can say it is a bounded sequence. See this example, Sn equal to minus 1 whole power n. When you are taking the sequence elements, what will come? Minus 1 plus 1, minus 1 plus 1. So, it is bounded by which numbers? Minus 1 and 1. So, it is bounded by both, that's why it is bounded sequence. Okay, in general, bounded sequence condition, when you are taking in a theorem, we are taking like this. Sn is bounded if and only if there exists a positive real number capital M such that mod Sn is less than or equals to M. So, this is the condition for bounded sequence where this is less than or equals to, which is nothing but supremum here. So, instead of writing infimum and supremum, we are taking modulus of Sn less than or equals to capital M, which is the condition for any bounded sequence. Similarly, you can see monotone increasing sequence. Monotone increasing sequence means either it may obviously we know what is an increasing sequence. Sn is less than or equals to Sn plus 1. First number is less than second number is less than third number is less than fourth number, and so on. Or it may be equal. Then we can say it is a monotonely increasing sequence. Similarly, monotone decreasing sequences, first number is greater than second number is greater than third number, and so on. This is called monotonically decreasing sequence. So, only Sn is only less than Sn plus 1. Suppose I am taking here increasing sequence means 1, 2, 2, 2, 3, 3, 3. This is increasing sequence. Strictly increasing means 1, 2, 3, 4 and so on. That means it should not be equal. It is only less than second number. It is less than or equals to second number means monotonically increasing. Only less than third number less than fourth number. Like this, it is strictly increasing sequence. Similarly, monotonically decreasing sequence 3 2 2 2 1 1 1. This is called monotonically decreasing. First number is greater than second number is greater than or equals to third number is greater than or equals to fourth number. This is called monotonically decreasing. Strictly decreasing means only greater than. That means 3 2 1 like this. This is called strictly decreasing sequence. Monotone sequence means any sequence which is either increasing or decreasing is known as monotone sequence. Suppose when you are taking this example, suppose when you are taking Sn, write Sn plus 1. What is the condition for increasing? Sn plus 1 minus Sn is less than or equals to 0 or greater than or equal to 0. Let us see. Okay. So Sn plus 1 minus Sn. Sn plus 1 minus Sn. When you are taking cancellation of this one, take LCM. N into n plus 1, then minus n plus 1, then it will be this. So obviously this is a positive number, it has no negative numbers because n belongs to integer natural number, so which is obviously greater than or equals to 0. Sn plus 1 minus Sn greater than or equals to 0 means take this into this side, then Sn is less than or equals to Sn plus 1, which is the condition for increasing. So Sn is an increasing sequence, that's why obviously it is a monotone sequence. That means monotone means either increasing or decreasing. See here also, by taking Sn plus 1 minus Sn, after simplification we are getting a negative number, that's why Sn is greater than or equals to Sn plus 1. So decreasing means it is a monotone sequence, monotonically decreasing sequence. See one more example, Tn is given like this. So Tn plus 1 means up to n plus 1, Tn plus 1 minus Tn, after cancellation we are getting this one. This is obviously positive means Tn is less than or equals to Tn plus 1. So it is an increasing sequence. Like this we can consider.